Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
And your co-host Rich Gear here as well, and we have a special guest, Ian Juby. We haven't talked to you in quite a while, have we?
Gentlemen, no, it's been too long.
You're going to talk about something that is really on the cutting edge, the cusp of what everyone's talking about right now, and I'm kind of excited because I'm going to basically not have to do much talking. I'm going to let you do it, or Doug, who are much more technological. But you're a robotics engineer, right, Ian?
Yeah, that's actually really one of the few things I actually went to school for.
But you have such an eclectic background. There's so many things you've done and are doing. You're just a fascinating guy. I just love seeing you and talking to you. It's been a while. So anyway, without any further ado, we're going to be talking about artificial intelligence today.
And Ian, I appreciate going on trips with you too. You know, I think we went to Joggins, went to Niagara Falls, and
Yep.
I think you were down in Biloxi with us as well one time.
That's right. Both you guys were down there.
That's right. Yeah, okay.
Yep. Both you guys were down there.
So we dug up some dinosaur tracks and
Had a snake chase me up the river. You remember that?
You as well, eh? Excellent.
That water moccasin, man.
Memories. Interestingly, on the Biloxi, that is another use of artificial intelligence technology, photogrammetry. Have you guys messed with photogrammetry at all?
don't think so, no.
No,
So basically, you take a whole mess of pictures of something, say a fossil human footprint that you just exposed, and you take pictures of it from all kinds of different angles. And there's free open source software online. You dump them into there, and it builds a 3D model with incredible accuracy using those images. So just like we see in stereo vision, it's looking at it from like 30 or 40 different eyeballs.
Well, let me ask you this question. I've got a 3D printer. I'm kind of wanting to get involved in doing some 3D printing, and I wonder, can you use something like that to actually 3D print a model?
Yep, and that is one of the things we're going to be doing. I'll be doing with the you mentioned before the show, before we started recording, the education programs I'm doing with the First Nations kids here in Canada. That's one of the things we'll be doing, because several of those schools have a 3D printer, and that's exactly what it is. Have you guys played Among Us, the video game?
No, I don't play video games. I don't play video games.
Okay, well, my sister knitted me this, right? So it's just one of the characters from Among Us, right? So basically, one of the students can take one of these, photograph it from 15 bazillion different angles, and all you have to do then is figure out the scale. So you can make it really big or really small. When I was working in Sioux Lookout for CN, we always had a spare locomotive parked in the rail yard. And so literally I could go out with my GoPro on a stick, walk around the locomotive, take like 50 photos, including the top, including underneath, drop it into the computer, and I can build a 3D model of that locomotive, complete with color. I can scale it, and then I can 3D print a scale model with incredible detail, all from photogrammetry. So it's pretty amazing what you could do with it, actually. So whoever that was, you absolutely can use it for that.
It's called photogrammetry. Is that what you call it? Or?
Yeah. I think we used to have in the museum some of those old stereoscope pictures where you could see things in 3D. That's the same principle, isn't it?
But you're actually building a 3D. How do you scale it? How does that work? You just in the computer?
In whatever 3D program you're using. So, I mean, I would typically use Blender, which is an open source, free 3D modeling program. And I use it for animations and stuff like that too, right? But I've also used it for making 3D models specifically for printing 3D models and stuff. So, I mean, coming back to the Biloxi tracks, if you uncovered a human footprint, you can, because by law, we're not allowed to remove the tracks from the riverbed. They just have to be left there, and they get destroyed over time by weather, right? So now we can document it. We just take 30, 40, 50 pictures, drop it in the computer, and we can literally 3D print a copy of that human footprint. for use in a museum, or if you guys wanted to use it at the museum there, Rich. It's very simple. It's shockingly simple, actually.
I'll have to come up and visit you because I don't understand a lot of this stuff. I really don't. I'm an art guy, So this I'm the old school. You hand paint things, you hand draw things, I use Photoshop, but you talk about animation. I don't understand any of that stuff. I mean, I understand it, but I don't know how to do it.
So let's get on track here.
Let's get on track. We're having some sidebars here, folks, because this guy's a very interesting character. He's a good guy.
I'm going to start out with a question. What is intelligence?
Ooh, that's actually a very good question.
And then how can we emulate it? How can we actually make it artificially? All right. So that is. So I make the observation is that evolutionists can't recognize intelligent design when it's right in front of them.
Correct.
And they devised a SETI program, and the scientists search for signals from outer space to see if there's any intelligent life outside this planet. And the only things that they can find are little reverbs from some of their own satellites.
Yep.
So.
They found microwave oven signals. I've already heard that.
That's right.
Yeah.
But they're clouded by their own bias that refuses to acknowledge God as a source of intelligence, and that's a dilemma. If they believe that they're a product of random chance juggling of atoms in the universe, and that they evolved, well, they must also conclude that their brain also evolved. And if that's the case, how can they claim to know anything about anything? So, Ian, what is intelligence?
Yep, and that's actually a really, really good question to kick it off with, because as I'll show you in a minute, the whole idea of neural networks and artificial intelligence is an attempt to mimic the brain. Problem is, we still don't know how the brain works. I mean, we're really in the dark as to because there's been a bunch of experiments where clearly memories and things like that are being stored outside of the brain. We don't know where. As us coming from a creation perspective, we might imply that perhaps the soul is what's storing those memories. But I mean, that's, it's debatable, right? It's speculation. The bottom line is, with artificial intelligence, they're basically trying to mimic the brain as we know it. And the other catch is, people don't understand this. This is all done with computers. Computers do numbers. That's it. There's nothing beyond that. They mash together numbers. That's all they do. That's all they have to deal with. That's all they have to work with. So to comprehend a picture, it can't. And we just recently, with my children's show that I'm trying to produce, it's a creation science show for kids, right? Animated series. And I've actually got a writing team now, which I've never had. 11 years of producing Genesis Week, I was it. I was the writer, producer, host, editor, closed captioner. I mean, I did it all, right? So now I've got a writing team, which I've never had before, and we're writing fiction. And this is an area which other people who are very much expert in AI have also said, and I would contend, AI cannot and probably never will be able to write good fiction, because the humans are putting nuances in it. Your plot twists produced by AI would just be bizarre. They would be like hard to put the words together, but like almost like contradictions. They would make no sense, right? It'd be these bizarre plot twists, and once in a while it might get it right because it just comes up with a plot twist, and it's, hey, that's actually a pretty good plot twist, right?
Yeah.
But anyway, but with intelligence now, of course, are you a member of Mensa, Doug?
I've never pursued that, no.
No, you never pursued. Okay, I couldn't remember if you were or not, because as you guys know, I mean, I started the special interest group within Mensa for creation science, and like Jerry Bergman's a member. G. Charles Jackson is another member. We had a bunch of members, right? So I'm a member of Mensa, and basically Mensa is this international high IQ society. Yeah. And what that means is when you have a really high IQ, what they're trying to do on an IQ test is measure how fast you think. And that is kind of what Sam Harris was getting at in his TED Talk on artificial intelligence, is because it's the AI is thinking incredibly fast. It's still ridiculously pathetic in comparison to human intelligence. But if you break it down into very specific tasks, because all it's doing is numbers, and it can crunch numbers way faster than we can, it can outpace us. So in those terms, it is already more intelligent than us because it can think faster. Right. But if you take, what was the name of that computer? Big Blue, I think. The one that the first computer that ran AI and beat the world chess champion.
Oh, yeah. Yeah,
it was Big Blue, yeah.
Was it Big Blue? Yeah. So where was I going with that? See, there goes my Mensa membership expired, so I don't know if that means I lose my IQ or not. I got to renew that. Yes, that's what I was going to say. So let's take Big Blue beats the world champion at chess at his own game, which was a world first. Now let's take Big Blue and put it in charge of flying a Boeing 747. That thing won't even get off the runway. It probably wouldn't even figure out how to start the engines. So in terms of comparing its intelligence, you have to put it into a very narrow field of focus to make any kind of comparison. So a computer that's good at chess is horrible at driving a Tesla. And the computer that's driving the Tesla is probably horrible at chess, would be my first guess. You wind up with a lot of weird stuff. So intelligence is ultimately, it's the speed of thinking. Okay. So if a person is more intelligent, they think faster than the average person. So the analogy I always made was having a genius level IQ just means you realize you did something stupid faster than the average individual realizes it, right?
Well, some of it, the ability to, like you said, if they don't know how to drive a Tesla, they can't fly the plane or play the chess. Aren't they trying to expand it where they can do multiple things? The AI is, and they keep building on it. But will they ever become what they're striving for is being self-aware? Isn't that what I keep hearing that anyway? Is that even a reality,
Well, that's kind of a really good question, because matter of fact, let me show you this real quick, even though this is just a screen capture. But I think this is a great quote and incredibly ironic that one of the lead spokesmen for the new atheism, Sam Harris, would wind up giving this TED Talk, can we build AI without losing control over it? Because with artificial intelligence in particular, we have a powerful and profound opportunity here to play God. Because why on earth would Sam Harris care about controlling AI? I mean, if he creates an AI and it becomes self-aware and it has free will, what's he going to do? Kill it?
We know that doesn't turn out well.
What's that?
We know that doesn't turn out well. I watched Terminator, man,
That's right. That's right. Yeah, and see what happens, right? But here you have this atheist complaining basically because, God imposed death upon humans for disobedience. Well, okay, let's put the shoes around on the other foot for a second here. And because now we get to play God. And this is kind of the point I was making with robotics is if I make a robot that's self-aware and I tell it, hey, don't do this or I will kill you. You will die. That doesn't make me evil. So if I kill that robot, if I destroy it, it's my robot. I can do whatever I want with it. I own it. I created it. I am neither good nor bad for creating it. I am neither good nor bad for destroying it. So we have the opportunity here to grasp a little bit, just a little bit, of what it must be like to be God and to create us with free will, self-aware. And what do you wind up with? You wind up with atheists declaring there's no God. So, I mean, it becomes really ridiculous.
It is a little ironical, yeah.
Yeah, I mean, my robots, could just decide that, well, I don't believe you anymore. I don't believe in you. And if I go up to them and say, well, here I am, and what are they going to do? Well, I don't care. I'm just not going to believe you. Well, is that robot intelligent or is it a fool? The fact that it has the ability to decide not to believe in me, that's pretty powerful ability. But anyway, I'm getting off topic. This is your fault, Rich.
I'm sorry. That's the kind of way I roll, Doug's been used to me for too many years,
That's right.
So show us that quote that Sam Harris.
Yes. Yeah, because I really like this, because he said this at the end of his talk. So he was talking about the implications of creating an AI, and he closed with, we have to admit that we are in the process of building some sort of God. He was referring to it having more ability than us, right? And thinking faster than us. Now would be a good time to make sure it is a God we can live with. I have to admit, I really liked that quote, as ironic as it is that a new atheist would be saying something like that.
Yeah.
But anyway, so with AI, you know what? Before I get to this paper, what is artificial intelligence? Okay, so specifically neural networks. Okay, so let's take one example here, and we'll go through this real fast, and hopefully people will get an idea of what it is. Something that to us is so simple, us identifying a written number on a piece of paper. You guys can see that there, eh?
Yep, 7.
Okay, so here's our camera here. These squares are the individual pixels of the camera. I kept it to 40, so 5 by 8, just to keep our neural network and everything small, so it can be, so you can see it, right? So you can grasp it.
Yep.
And we've trained this AI already, so that the ideal number 7 written on a piece of paper, you can see in light blue here, I've got the pixels that it thinks is the ideal number 7. Okay. I've taken all these pixels. So there's the first 5. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I've put them all in a column here. And you can see I've actually highlighted in blue the ones we would look for if it was the number 7, the ideal number 7. And I've also highlighted the pixels that have majority black. So we would call them a black pixel, right? And so ideally, if we were to identify the number 7, all of these black dots would be on all of the blue squares. Can you follow me there so far?
Yep.
And ideally, all of the squares that are not the number 7 would all be white, no black at all. So you wind up with the lines, of course, because people's handwriting is all different and everything. Some people draw their numbers 7 different. Right. So here's our first neuron. And basically what they did is they looked at the human brain. They see all these brain cells all connected in this web. They're all connected to each other, right? So they're trying to mimic that. And so how they do that is they'll have, here's the black neuron and here's the white neuron. So this one's looking for which pixels are black. This one's looking at which ones are white. And because it's looking for the number 7, the black is looking to all the squares that it's expecting to be blue. And it's looking to see if they are appearing black or not. At the same time, it is also looking at the white areas. That's just as important. And so what it'll do is it'll come up with, you can see some of the black dots, like this one did not get black. This one didn't as well. This one didn't.
I was going to ask you about that. Okay.
Yeah, and it's just the way because the person, when they drew this number 7, you could see this one wound up over in this pixel instead of this one.
Yeah.
So that's why this one wound up black instead of this one. It's just variations, right? So your incredible supercomputer in your head just takes one look at this, and in the twinkling of an eye, you can spot it. So this is extremely difficult. Something that's so simple for us is actually really hard to do by computer. But this is how they do it. So what they're doing is they look at the white and they look at the black, and they simply perform a bunch of math. They're expecting 12 squares. Ideally, 12 of those pixels would be black. Only 9 of them are, but that's a 75% match. At the same time, they've got 28 pixels that they're expecting to be white. Only 27 of them are, but still, that's a 96.4% match to the ideal number 7. You follow me so far?
Yeah.
Okay, so we now take those two numbers, and this is another neuron, and all these are, Doug, you did a lot of computer programming, right?
Yeah, I did.
Oh, yes, yeah.
Yeah, so all these are arrays. That's it. They're just arrays and math functions. That's it. So this is an array, and these are math functions, reading the arrays and performing math. That's it. Nothing complicated. And so we wind up with your blacks. It's going to look for, if it's going to take its best guess, it's going to say, okay, if this is the number 7, then the blacks should match somewhere between 65 and 100% of the pixels I'm expecting. At the same time, the whites should match, probably, 75% to 100%, somewhere in that range. If I wind up with two numbers in those ranges, there's a really good chance that it is a number 7. And so it might, in this case, it works out to about an 85.7% match is the way it works out. So at the same time, it's also checking, because there's these neurons as well, for every single one of these other numbers. They've all got their neurons as well. So you can start to see why they call it a neural network, because you got all these webs of quote unquote neurons, right? And so for the number 0, it might only be a 5% match. Number 1, it's a little better of a match, but it's still only 54%. And it just goes down the list, does this very fast. The best guess is the number 7, which has the highest percentage of a match. So it's just under 86%. So what happens then is the AI spits out a guess. And it's not always right, but it spits out a guess and it says, I think that is the number 7. It comes out with the best guess is the number 7. Now, in this case, it's correct. Okay? But let's say it's not. It's actually number 1. It's just a sloppily drawn number 1. Somebody has to tell the AI whether it's right or not. The AI does not know if it's right or not. It's taken its best guess. If it is wrong, there's a couple things it can do here. So, and this is where what they call machine learning comes in, because if it's wrong, so a person, an outside operator tells it, no, that's the wrong answer. It then takes a look at all its calculations, all its numbers, and it can do a few different things. It can modify the percentages. It can modify which pixels it expects to be dark, which ones it expects to be light. It can modify the ratios. It can modify the percentages. It's all math. That's it. So you guys follow me so far, right?
And if you increase the number of pixels, so the chances of it being right are a little bit increased?
Yes. And it unfortunately gets to like really, really, really big numbers really fast. Because I mean this is a 5x8 pixel frame.
Right. Well, how does this work? I guess my thing is consciousness is different than numbers, it seems like, or is it, I guess I don't understand how the relationship is there.
What's different than numbers? Sorry?
Consciousness or seems to be self-awareness is way different than just mathematical calculations.
Exactly. So
Okay.
so you can see what's going on. Here, I'll show my screen again. Sorry. That is actually an excellent question. And I'm glad you brought it up because that's a significant point. So it is interpreting what it sees, translating it into numbers, because that's all AI does. Numbers. That's it. It does not comprehend it doesn't comprehend anything. All it's doing is it's spitting out numbers and seeing if the user tells it if it's correct or not. That's it. And if it's incorrect, it tries to change its factors so it can try and better guess. So the reason I'm explaining all this is because, as you very much eloquently asked, Richard, is there is no consciousness here. And that's the point that needs to be brought home. This is a computer looking at numbers.
And it's really not intelligent either in that term. And you need a moral outside. The intelligence can't be greater than its creator.
Bingo. And we were talking about this before the show. I was using Midjourney AI, right? And you put in text, and so what it does, you put it into text. It's just like doing a Google image search. Google looks at keywords attached to images, and so when you punch in your keywords, it goes and tries to find images on the internet with tags and keywords that match what you put in.
And I tried mother-in-law pickle pie, and it came up with something really funny. I'll show it here. But we only have a less than a minute left.
Yeah, so how do you want to wrap this particular show up, Ian?
Okay.
What do we want to leave us with?
Okay, well, I was going to say, what Midjourney AI does for generating art, it does an image search using keywords, and I put in the keyword search for charismatic Baptist Simpsons meme, and this is one of the images it came up with. Very creepy, but it went look at
Frankenstein.
It went and looked at pictures of the Simpsons and pictures of Baptists and pictures of charismatics and pictures of memes, and it put them all together, and this is what it came up with.
Wow!
Oh, that's terrible, huh?
It hasn't got a clue what it's doing. It does not comprehend any of this. It's just punching out numbers. That's it. There's your AI. That's all it's doing.
Wow. Well, Ian, it's been a pleasure having you on our show. We'll see you next time on Revolution Against Evolution.
Yeah.